Today, we're going to analyze Southern California wildfires. This is part 2. Alright, let's move on. Okay, now here we go again. Another car out in the middle of nowhere, completely destroyed. Where did the fire come from? Oh, let me guess. Magical embers, right? Alright, let's move on. Let's take a closer look at this car. Now, you will notice that there's no glass, no shattered glass anywhere. Okay, this glass was vaporized. What temperature does it take to vaporize glass? You see any glass anywhere in this truck? Look at the bed, completely destroyed. I don't see any shattered glass anywhere. And again, out in the middle of nowhere, where did the fire come from? It looks like maybe some melted glass, but there's no shattered glass anywhere in this car. Now look at this truck. This piece of steel channel has a bend in it. Okay? Now when you look at a 2x4, to see if there's a bend or a warp in it, you look at the 2x4 from the end of it. Okay, and it's the same principle here. We're kind of looking at it from the end, but on an angle, so you can see the bend in the steel channel. Okay, let's move on. And that's a heavy-duty steel channel. And look at the channel on the inside. It's all bent and twisted and warped. There were wood planks on top of this. You know, they're completely gone. What temperature does it take to bend a heavy-duty steel channel? Okay, a normal fire doesn't get hot enough to do that. Okay, this isn't normal. Alright, let's move on. And you can see the diesel tank is still intact. Look how bent that is. Normal fires don't do that. And again, we see no glass. We don't see any signs of shattered glass. Look at that sidewalk. How did it get so fucked up? There's probably rebar inside of that sidewalk. And the magnetic property of this exotic weapon disturbed the rebar, therefore cracking the sidewalk in such a manner. Okay, now that's just an idea. Okay, let's move on. A wildfire doesn't destroy a sidewalk like that, especially when it came out of, you know, where did this fire come from? Okay, didn't come from the forest. Oh, let me guess, magical embers. Once again, right? No signs of glass. Look how bent and twisted that is. The pieces of steel channel. No. Oops, let's back up a little bit. Now this is interesting. Now I don't know if this was put here afterwards. It could have been. Alright. Then again, maybe not. A piece of cardboard still intact. You know, this fire was hot enough to melt and twist, you know, this heavy duty steel structure. Burn all the planks, but yet the cardboard is intact. There, you can clearly see it's cardboard. You know, alright, let's move on. Alright, now on to the next video. Alright, the first thing we notice in this video is the bent pipe. Okay, well, let's move on. It gets better. Alright, wait until you see this. And here we go, coming up. Look at that I-beam. Okay, that's a hardcore, heavy-duty I-beam. Completely twisted and bent. House fires cannot do this to an I-beam. Okay? Let's take a closer look at it so we can look at it a little closer. I mean, look at this I-beam. Look at the thickness of that I-beam. Completely twisted, bent, warped. House fires don't get hot enough to do that. People need to start waking up. Alright, let's move on. Okay. Look at that piece of channel. That's a heavy-duty piece of steel channel. Look how thick it is. Bent, twisted, and warped. The evidence is mounting up. And look at the glass. Completely melted. Alright, let's move on. Okay, look at these cars. The roof is caved in and they're bent and twisted. Alright? And you're going to try to say that a wildfire does this? Alright. And here's another image of that truck. You can clearly see that this piece of channel is bent. Alright? Move on. Now, let me show you something else I found of interest. It's not as in your face. It's just something I found interesting. Okay. Look at that car. Alright? Look how mangled it is. Okay? And look at the torsion springs. You know, these are garage door torsion springs. Okay, we'll take a closer look. This is, I'm guessing, probably a 10 by 10 opening. But let's take a closer look at these torsion springs. Now you can see, okay, this is two separate springs. Okay, and in the center, you have, on the ends, you have winding cones that are made out of aluminum. Okay, they're completely gone. Okay, and you usually have a center bearing plate with stationary cones that connect to the center bearing plate. They're gone. Okay, and this shaft, this is a 1-inch hollow shaft. And the idea of the spring, I'm guessing, is probably 2 5/8. Okay? And look at this right here. What's that? It could just be a puddle of aluminum on it? Or did that actually melt this spring steel? Okay? We'll take a look at this spring over here. And over here, on the end of the shaft, are drums. Okay, they're also made of aluminum. Okay, the aluminum drum is completely gone, but yet the set screws are intact. Okay, the set screws fuse to this 1-inch piece of tube. Okay, or the other way around, because the tube is softer. Okay, you can see the same winding cones gone. You know, same thing. I just found out of interest. You know, the aluminum can melt in a fire. All right, that's it. All right, wake up.